Okay, this problem states the equiangular hexagon shown has four congruent sides of length A and two congruent sides of length B. Write a formula for its area in terms of A and B. Okay, we've got to remember some geometry here. Okay, pause. Remember if you're going to try to as you try this at home. But if and now if you're hearing my voice, you've unpaused it. You're back. Maybe you're checking if your solution is like mine. So how do we find this out? Well, we got to remember how many. This is equiangular. I mean, we've got 6 equal angles. And by the way, this is just a straight line. Not. It's just a mess up in drawing it. And it's obviously not to scale. This is also a straight line, and they're equiangular, so these angles are all the same. So what do all the angles in a hexagon add up to? Well, in a triangle they add up to 180, in a quadrilateral 360, in a pentagon 540. So in a hexagon it's 720, and 720 divided by 6 means every angle there is 120 degrees. 120. All right. Then the next point is we need a formula for the area of the thing. Now the area of any polygon, any regular polygon. So this is not a regular polygon. So I guess maybe we have to divide it up into little shapes. We've got a rectangle here and 2 triangles. Maybe that's one way to do it. And if we look at then the rectangle becomes, it's got sides of, it's got B and B, and then whatever this height is. Then we've got 2 triangles, and the triangles look like this. And this dimension here is the same as this dimension here. And this is A, this is A, this is 120 degrees right here. So these are 30. So again, I'm going to dial this back a few notches because that's just getting in the way. It's getting in the way because I want to divide this up. If those are 30 on the edge, then I've got 30, 60, 90 triangles I can make out of these little things. And these 30, 60, 90s have A as the hypotenuse. Now that's 30. So this here is 1/2 A. And that means this here, I'm just going to make a star because I don't have enough space. Or maybe I'll just write with a smaller pen. Like, man, this is boring, Mr. Dittmer, I know. But this would be root 3 over 2A. And that's important for us because that's this right here, and we're trying to find all this. So now we know that this right here is root 3 over 2A times 2, or just A times root 3. So if we're trying to find the area, well, this clearly is AB root 3. And this here, well, I just want the area of this whole deal. It would be, this is A root 3, and this is 1/2 A. So the area of this here triangle would be 1/2 base times height. Well, 1/2 A times A root 3. That's the area of, and now there's 2 triangles like that. So 2 times that means we can get rid of that. And so the area of the two triangles together is this, 1/2 a squared, or a squared over 2 times root 3. The area of the rectangle is BA root 3. And so the area of the whole shape is BA root 3 plus a squared over 2 root 3. And I'm going to check the answer now because I think I did that right. A squared root 3 over 2 plus AB root 3. Each angle of the hexagon is measured 120 degrees. Bisect the angle labeled B, this angle here, and construct segment AC, this segment here. And the four sides with length A form the hypotenuses of four 30, 60, 90 triangles. 1, 2, 3, 4. With short leg A over 2 and long leg A root 3 over 2, the sum of the areas of those four triangles is 4 times A over 4 times A root 3 over 2 equals A squared root 3 over 2. The area of the rectangle is B times A root 3. Alternate solution, construct the diagonal through B parallel to side CD. You don't need to know this. But if you don't need to know it, you can just press pause and stop watching. But here you are, continuing to watch. So let's continue. They're saying a diagonal through B parallel to. They're saying construct this. This is the second alternate solution. I'm going to give it a different color here and draw this diagonal. This segment creates two trapezoids, each with bases B and A plus B. So because this is 1/2 A and this is 1/2 A, so this red line is A plus B. And the height in both cases is A times root 3 over 2. So using the formula for the area of a trapezoid, you can work it out that way. Woo!